All right, so we're going to start off with some polynomial long division here. And so I say it's kind of like long division of numbers by hand. And so if I'm dividing these two right here, oh, it does say put placeholders for any missing powers. So I would write this polynomial 8x to the fourth plus 0x to the third plus 6x squared minus 3x plus 1 on the inside, and then I'm going to put 2x squared minus 2 on the outside. Okay, and so now that it's set up, I'm going to do the first thing on the inside, and kind of my answer here is going to be determined by doing this a few times. So I'm going to put the first term on the inside over first term outside. And so we're going to divide that and see what happens here. So I'm going to start off by doing 8x to the fourth divided by 2x squared. And so that comes out to 4x squared. So that's going to be part of my answer. I'm going to put that up here. And then my next step here is going to be to take that and multiply it. Take that 4x squared and multiply it by the front. So 4x squared times 8x squared is going to give me 8x to the fourth. I'm going to put that underneath its like term here. That should really always match up with the first thing inside. And then I also have to do 4x squared times negative 2. And so that is negative 8x squared, which I will put under its like term. Okay, so then next up, I need to subtract these. But since we're subtracting multiple terms here, that requires distributing the negative. So I'm going to switch this to addition and make this a negative and make that a positive. So always make sure you're switching the signs there. So these cancel out. I would bring this one down if there was something there, but there's not. So I'm actually just going to cancel that out as well. And so I get 14x squared minus 3x plus 1. All right, so now I'm going to do another round of first thing inside divided by first thing outside. So that's going to be now the new first thing inside is 14x squared. Same first thing outside is 2x squared, so that's going to give me just 7. So I'm going to put that up here with its like term. And then I'm going to, and so since I have no x's left there, I actually know that this is going to be my last round of this. So I'm going to multiply that by the front. So 7 times 2x squared would be 14x squared. And then 7 times negative 2 would be negative 14. And I'm going to switch this, I'm going to put a negative out front and then switch these signs. So that one's going to become a negative and that one's going to become a positive. So these will cancel out. This will come down as a negative 3x plus 15. Now 3x doesn't divide, negative 3x doesn't divide by 2x squared. So this is actually my remainder. So sometimes they'll list that as just the remainder at the end. So let me go ahead and write my answer down here. So the two ways that they can write this answer are, I could write it as 4x squared plus 7 with a remainder of negative 3x plus 15. Or very often, they will go ahead and take that remainder and put it over the thing we were dividing by. Because we're saying we didn't really get to divide this by 2x squared minus 2. So you can show that as a fraction, show the remainder over the thing you were dividing by. All right, next up here we have what's called synthetic division. So synthetic division we can only do if we're dividing by the first power. So they say it's in the form of x minus c. And so you can set up like below. So you put the coefficients as the numbers up here. So you can see the 2 got put there. The negative 7 got put there. We needed the 0 because there's no x there. And then we put the 5 over there. And then you can see that we switched the sign of the number in there with the x, and that went in what I call the cupboard. Okay. So how we do this one, we just bring this one down right away. So this first one always stays the same. It's a very common mistake because people change that first one, so don't do that. Just bring it down as whatever it is. So in this case, it's a 2. And then every time I go back up, I'm going to multiply by whatever's in the cupboard. So in this case, that's going to be 3. So I'm going to multiply by 3. So it's going to give me a 6. And then I'm going to add down. So it's going to give me, in this case, negative 1. Now I'm going to multiply by 3 as I go back up. So it's going to give me negative 3. Add down will be negative 3. Multiply by the 3. So that'll give me negative 9. And then add down will give me negative 4. So So now those are my coefficients here, and so how I interpret them, if you start on the far right side, that's always your remainder. The next one's your number, and then we have the x, and then we have the x squared. If we had another one, it would be x to the third, and then x to the fourth, and so on. So then we have our final answer here would be 2x squared minus x minus 3. And when I say minus x, it's really minus 1x. And then here we have our remainder of 4, which once again, you can just put that as 4 over x minus 3. So that's one way to interpret the answer. The other way is anytime you do this, since you're dividing by the first power, this power is going to decrease by 1. So it's going to go from 3 to 2 for your leading for your degree here. So if I was starting off at the fourth power and I used synthetic division, I would end up in the third power. All right, next up we're going to use another application of synthetic division, which is called the remainder theorem. So I'm just going to do part A first. And so that says synthetically divide f of x, so that function up there, by x plus 2. So if we're going to use x plus 2, we have to switch that. And so negative 2 is actually what goes in the cupboard. And then so I'm going to put the coefficients up here. I got 3, 5, negative 4. I'm missing the x squared. So I'll put a 0 there, and then I got 7, and I got 3. So I'm going to bring down the 3 here. And then I'm going to multiply by negative 2 every time I go back up, so that's negative 6. Add it down is negative 1, multiply back up is 2, add down is negative 2, multiply by the cupboard, which is negative 2, that'll be 4, add down is 4, multiply by the cupboard would be negative 8, and then this one's negative 1 if I add down, multiply by the cupboard is positive 2, and then that gives me a 5. And so my answer here, if I dropped down by 1 power, so I started at the 5th power, so this will be 3x to the 4th, minus 1x to the 3rd, minus 2x squared, plus 4x, minus 1, and then our remainder we'll put over x plus 2. All right, so that's the synthetic division there. And so now part B says, what is f of negative 2? So f of negative 2, how we would have done that before is we would have plugged in negative 2 for every single x here and seen what it comes out to. But the remainder theorem says that if we put this negative 2 in the cupboard, then whatever we get for the remainder is actually our answer. So f of negative 2 equals 5. So if I would have plugged in negative 2 for all of those x's and typed it in a calculator, it would have actually come out to 5. It's pretty amazing if you think about it. If you'd like to go ahead and check that and plug in negative 2 for all those, make sure when you do exponents with negatives, you use parentheses, but your answer should come out to 5, but we can just do it by synthetic division. So I love the remainder theorem. I think it's a really cool concept there, okay? Now, one thing I want to point out here is that the number inside of the f here matches up with the number in the cupboard, as opposed to when it's written as x plus 2 or x minus 2, we always switch it. But when it's x equals negative 2 here, because this is saying x equals negative 2, that we keep it the same. So it's just if it's x plus the number or x minus the number, do we switch it. When it's the f of, we just put that number in there, okay? Okay, so then next up here, same idea. We'll do it with x minus 1/2. So we're going to put 1/2 in the cupboard. We have 4. We have our missing power of 0 there. We have to be careful of. So I'm going to multiply it by 1/2 going up. So we'll get 2. Multiplying by 1/2 just means dividing by 2. And so now I'm going to multiply by 1/2 and it turns into 1. And multiply by 1/2, that turns into 5. And we get a 6 there. So this would be 4x squared plus 2x plus 10. With our remainder of 6, we'll put over x minus 1/2. And so then we can use this to say that f of 1/2, if I was to plug in a 1/2 for all those x's, it would actually come out to just the remainder, which is 6. All right, next up here it says, what would be the remainder if I had this function and that was divided by x plus 1? So if I was to do this, I would plug in the negative, or I would put the negative 1 in the cupboard here. And I'd have to put a 1 here for the x to the 1,000th power. I'd have to put a 0 here for the 999th power, 0 here for the 998th power, and I would have to keep doing that for a long, long time until I got to eventually a negative 5. And then I have to do like 497 more zeros, and then a 3, and then 2 more zeros, and then negative 10. So that is not seem like it's worth my time. There's got to be a different way to do this. And so this one says, how does remainder theorem work backwards? So instead of doing this and figuring out what's in that remainder in the last box, can't I just find out what is f of negative 1? Yes, I can. And so I'm just going to do that instead because that number must always match the remainder. And so that's actually easier to do in this case. So I'm going to say negative 1 to the power of 1,000 minus 5 negative 1 to the 500th plus 3 times negative 1 to the power of 3 and then minus 10. Now this is actually possible. Negative 1 to any even power is 1. And negative power to, oh, this is 5 times 1 then. And then negative 1 to any odd power is negative 1. So then I get 1 minus 5 minus 3 minus 10. And so f of negative 1 sounds like it is, so we got negative 18 plus 1, so that'd be negative 17. So since f of negative 1 is negative 17, I can safely assume that the remainder, if I would have actually done this, is also negative 17. All right, next up we have the factor theorem, and the factor theorem is actually related to the remainder theorem, I think. And so it says if we synthetically divide by c and the remainder is 0, that means then x minus c is a factor of f of x. Okay, so this is saying that if we get a remainder of 0, we know that if we plug in whatever the c value is, we're going to get out 0, and so that would be an x-intercept, if you kind of think about it. If that was like 5, 0 or negative 5, 0, that would be an x-intercept, okay? Okay, so then how we're going to do these ones is, at first here, they're going to suggest, hey, let's try out 1/3 here, so we're going to go ahead and do that. And so I'm going to put 1/3 in the cupboard. Now, notice I'm not doing negative 1/3 here because they didn't put x plus 1/3, they just put 1/3. So if it was x plus 1/3, I would have switched it. But if they just give you the 0 there, if they just give you the number, you just use that number. So I'll put my polynomial here. I got 27, 27. Got to put 0 for the linear term there, the x term, and I'll put a negative 4. So we'll bring this down as 27, and then I'm going to multiply that by 1/3, which that's just the same as dividing by 3, so that's going to make it 9. I'll add this down, so it'll be 36, and then multiply that by 1/3, which again, dividing by 3 would make it 12. Add that down, and then divide it by 3 one more time, which can give me 4, which will give me 0. So how we can write this now is we have x minus 1/3 for the number that was in here. Okay, so as I said, we can write it right here, and then times whatever's left over from the synthetic division. So since I started at the third power here, that means that's 27x to the second power, 36x, and then 12. And so from there, we can factor the leftovers using other techniques, okay? So the first technique that I see here, I see that all of these numbers are divisible by 3, so I definitely want to do that first. So I'm going to GCF a 3 here. So I'm going to say x minus 1/3. I'm going to take a 3 out front, and then we'll make this 9x squared plus 12x plus 4. And now we're going to actually, before I refactor that, you can usually, when this is a fraction, you can send this back in here. So I'm going to call this 3x minus 1. Make that all integers. And then we'll go ahead and do our x on this. So I think of two numbers multiplied to a times c, which is 36, and add to b, which is 12. So it sounds like 6 and 6. Now I do need my grouping technique here. So I'm going to split this up as 6x and 6x. And I need that because I have this 9x squared out front. And then I'll put that 4 out back. Okay, so now we'll do our grouping technique. So the first group I can take out a 3, which gives me 3x plus 2. The second group I can take out a 3x, which leaves me with 3x plus 2. The second group I can take out a 2, which also leaves me with 3x plus 2. So this actually comes out to 3x plus 2 times 3x plus 2, which I would just call 3x plus 2 squared times 3x minus 1. So it says to find all the remaining zeros of the function. So I would say that x equals negative 2 over 3 for this one, and that is a multiplicity 2, since it was squared. All right, so we'll try this one more time with number 7 here. So they're suggesting to use 1/2 here, so I'll go ahead and do that. And so I'm going to put 2, 1, negative 13, and 6 here. So we're going to bring down the 2, multiply it by 1/2, add it down, multiply by 1/2, add it down, multiply by 1/2, and we got our 0. So now we have x minus 1/2. And now I'm going to switch it when I write it in this form. And then this one is 2x squared plus 2x minus 12. I see we can GCF a 2 here. So I'm going to go ahead and do that. X squared plus x minus 6. And now I'm going to factor this with two numbers multiplied to -6 and add to 1. So that would be 3 and -2. I can actually use the shortcut here, so I can put x plus 3, x minus 2. And I'm going to go ahead and send this 2 in there, so that'll call it 2x minus 1. So my other two zeros are -3 and 2. All right, next up here, we have number 8. So this one, you can see they actually gave us 2 zeros here. So I'll show you what happens on these ones. You can start with whichever one you want. I'll just go ahead and go with the -1/4 first. So we got 4, -35, 91, -59, and -21. I don't see any missing powers there. All right, so we'll bring down the 4, multiply by -1/4, make this -1. Add that down, multiply by -1/4. Again, I'm just really dividing by -4. It's going to give me 9. So that'll be 100, -25. See, that'd be -84, which would be +21. That'll give me 0, so that's good. All right, so whenever you're doing this one and you're doing 2 zeros, when you get the first one, just take the leftovers here and use the next one on the leftovers. Don't go back to the original. And what that's going to do for us is this is now the x to the 3rd to start with it, but if it works again, then I'm going to drop to the x squared. So I'm going to bring this down as a 4, multiply by 3, it will give me 12, -24, -60, 72, 28, and 28 times 3. I'm hoping that that's 84, and it is +84, so that gives me my 0. Okay, great. So now we can write this as x plus 1/4 for the -1/4 up there, x minus 3 for the 3 right there. And then now I have dropped down to x squared. So it just dropped down by 1 every single time. So I start at the 4th power, drop to the 3rd power, and now at the 2nd power. Love the 2nd power because now we can factor. So I'm going to GCF first. So all of these actually divide by 4. And then I always send that 4 into the send that GCF into the fractional one. That'll make it an integer. So this will be 4x plus 1, x minus 3. And do my diamond here, so I got 7, -6. And there's actually no numbers that work for that. If you're thinking of -7 and +1, that does not multiply to make a -7, or does not multiply to make a +7. It multiplies to make a -7. So factoring doesn't work here, and so this one is a no-go here. And so if that happens, then we have to switch to quadratic formula. So for quadratic formula here, we're going to do it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I have here my a is 1, my b is -6, and my c is 7. So that's going to be +6 plus or minus the square root of -6 squared is 36 minus 4 times 1 times 7 all over 2 times 1. And so that's going to be 6 plus or minus the square root of 36 minus 28 is 8 all over 2. The 8 we can break down here. I just break it down into the prime factors and look for twins. So these twin 2's get to go outside. So we get 6 plus or minus 2 rad 2 all over 2. And then if you can divide all 3 of these numbers by anything, then you can. So I can do that here. So I'd say my final answer for these zeros is 3 plus or minus rad 2. All right, next up here we have a sample SAT question that I saw in a practice test, so I thought I would grab it here. So it says, for a polynomial p of x, the value of p of 3 is -2. Which of the following must be true about p of x? So looking through these options, option A really doesn't make any sense to me. It says x minus 5 is a factor of p of x. So if it was a factor, that would actually mean that p of 5 would equal 0. Remember, if x minus 5 is a factor, that means that if I have the 5 in synthetic division, my remainder would be 0. So that would mean p of 5 is 0. Option B is saying p of 3 would be 0. Now that's kind of related to what we're talking about, but they didn't say p of 3 was 0. They said p of 3 was -2. Option C would mean that p of -2 is 0. Once again, anytime it's talking about a factor, that means that this is coming out to 0. Now, D is going to be our correct answer, because if you have x minus 3, that would mean that if I plugged in a 3, it would come out to -2. All right, next up here, we are going to write polynomials, and we're going to expand them into standard form. So here we have, they give us the polynomial with degree 4, and the zeros are at 1 with multiplicity of 2. So we know if we have a 0 at 1, we're going to put x minus 1 and then x minus 1. And then they say -3/2 and +3/2. Now, whenever you have a fraction, you're always going to move the bottom to the front. So I'm going to call this one 2x plus 3. We do always still switch the sign, just like you do with that +1 there. So this one's going to be 2x minus 3. All right, so these first two here, we have to do a full FOIL here. So I have x times x is x squared. X times -1, -1x, and -1x makes -2x. And then 1 times 1 is 1. Or actually, -1 times -1, but it's still 1. Okay, these back here are actually conjugates, and anytime you have conjugates, which means it's the same thing but a different sign in the middle, you actually don't have to do a full FOIL, you can just FOIL. So I can just do first times first here is 4x squared, and last times last there is -9. So that's a little shortcut there for conjugates. Once again, it's got to be the same, but one positive, one negative. So x minus 1 is not a conjugate with x minus 1. I had to do a full FOIL back here. If I had x minus 1 and x plus 1, I could FOIL. So this one is our FOIL. So we have one positive and one negative. All right, so now I need to multiply these two together. I like to use a box for this, so I'm just going to build a 3x2 box underneath this one. I'm going to put 4x squared minus 9 here. And so I'm going to multiply to fill this out. So I got 4x to the 4th, -8x to the 3rd, 4x squared, -9x squared, 18x, and -9. And I'll just combine like terms for my final answer. So I got 4x to the 4th. I just have -8x to the 3rd. The only ones I'm combining here are the 4x squared and the -9x squared. So that's going to make -5x squared plus 18x minus 9. All right, similar idea here for number 10. So for this one, we're going to do 2x plus 1 for that -1/2. Remember, bottom to the front and switch the sign. And here we have x minus 2 and x minus 2. We have x minus 4. And then we have 0 with a multiplicity of 5. So it's going to be x to the 5th power. All right, so we can go ahead and start multiplying these. I don't see any conjugates, so there's no shortcuts here. So I'll just multiply these two together. So this will give me 2x squared. -4x, +1x is -3x, and then -2. And then over here I have x squared, -4x and -2x is -6x, and then -2 times -4 is +8. I'm going to distribute this x to the 5th in there at the very last step. So I'm going to multiply these two together now. I'm going to use a box. And I'll put the x squared minus 6x plus 8 on the side here. So we get 2x to the 4th, -12x to the 3rd, 16x squared. And we have -3x to the 3rd, 18x squared, and -24x. We have negative 2x squared, positive 12x, and then negative 16. All right, so I'll go ahead and write this out. So we're going to have x to the 5th out front. I have to distribute that in a minute. We have 2x to the 4th minus 15x to the 3rd if I combine these guys. And we'll add these up in here. So that's a negative 2, a positive 18, and a positive 16. So that is going to give me a positive 32x squared. Negative 24 and positive 12 will give me a negative 12x. And then I have the negative 16. Okay, so then last step here is I'm just going to distribute this x to the 5th in there. So it's going to give me 2x to the 9th minus 15x to the 8th plus 32x to the 7th minus 12x to the 6th minus 16x to the 5th. All right, next up here, same idea, except we need a quadratic coefficient of 22. So quadratic is the x squared term. So I deal with this at the very end. I'm first gonna just do what I was doing before. So I got 1/2, so I'm gonna put 2x minus 1, put x minus 2, and then x minus 3. Multiply any two of these together. I'll do these two, so I get 2x squared minus 2x minus 1x, and it's minus 5x, and then plus 2. And then times x minus 3. All right, now I'll multiply these two together. I like to use the box here. So x minus 3, we get 2x to the 3rd, negative 6x squared, negative 5x squared, 15x, and then 2x, and then negative 6. So I would normally put this as 2x to the 3rd minus 11x squared plus 17x minus 6. But now we're going to go back to this quadratic coefficient of 22. So I want my x squared to have a coefficient of 22. That's a positive 22. So I need to multiply this whole polynomial by a number that's going to make that happen. So to make that a positive 22, I'd have to multiply this by a negative 2. So I am allowed to do that because it doesn't change the zeros. The zeros will all be the same, but I can just change the coefficient. So this will be negative 4x to the 3rd plus 22x squared minus 34x plus 12. So we have to apply it to every term. So there's going to be my final answer. All right, lastly, we got number 12 here. So same idea with that constant coefficient of negative 6. We'll deal with that at the very end. First, I'm going to deal with all of these. So I'm going to put this one as 2x minus 3. We'll go x plus 1, x plus 1, and then we have x plus 3. Okay, so we'll start multiplying together. I don't have any conjugates here, so no shortcuts. X plus 1 is not a conjugate with x plus 1. 2x minus 3 is not a conjugate with x plus 3 because they're not the exact same. So I'll just multiply these two. 2x squared plus 2x minus 3x is minus x, and then minus 3. These ones I get x squared plus 3x plus 1x plus 4x, and then plus 3. All right, so now we'll multiply these guys together. X squared plus 4x plus 3. So we get 2x to the 4th, negative x to the 3rd, negative 3x squared, 8x to the 3rd, 6x squared, negative 4x squared, negative 12x, negative 9, and then this one will be negative 3x. Okay, so now I'll just combine my like terms. So I got 2x to the 4th, I got 7x to the 3rd, I got, let's see, negative 7 plus 6 would be negative 1x squared, negative 15x, and then minus 9. Okay, so this one's talking about the constant coefficient. So the constant coefficient is actually the one back here. So we have this one would be the cubic, this one would be the quadratic, this one would be the linear, and so the number out back with no variable is the constant. So we need the constant to be negative 6. So I'm thinking I need to multiply this by something, and I'm thinking, what can I multiply negative 9 by to turn it into negative 6? Well, if I divide it by negative 9, that turns into x equals positive 2 over 3. So I'm going to have to multiply this by 2 over 3. So I have to distribute that in. So this will be 4 over 3, x to the 4th. 14 over 3, x squared. No, x to the 3rd. Negative 2 over 3, x squared. This one actually reduces, so that'll be negative 5 times 2, negative 10x. And then that'll give me my minus 6.